in and look at today's lesson. What we're looking at today is addition, subtraction, and multiplication of these higher degree polynomial functions. Now, there's two ways we can do addition, and that's either going to be vertical or horizontal. Now, vertical is just going to be straight up and down. Now, once we kind of write this out, and once I write it out, it'll make more sense of what we're talking about. But with addition and subtraction, we can only add or subtract like terms. We can only add or subtract like terms. So the first equation we have is 3x cubed plus 2x squared minus x minus 7. And when we add or subtract, we really, especially with vertical, when we add vertically or subtract vertically, we want these equations in standard form. And here we're adding. Now the other equation is this one here, x cubed minus 10x squared plus 8. So I'm going to line them up. So we have 1x cubed, then negative 10x squared, so it's going to go under the x squared. Do I have a term that's just x for the second one? No. So I'm not going to write anything under this negative x. And then we have plus 8. I'm going to line them up. So the x cubes are over the top of each other. The x squareds are over the top of each other. The x's are over the top of each other. Bless you. And the constant terms are over the top of each other. So they all line up. Now what is it asking us to do? It's asking us to add 3x cubed plus x cubed. Be 4x cubed. 2x squared plus negative 10x squared. Negative 8x squared. Minus x, because since there's nothing there, it just comes straight down. Negative 7 plus 8 is? Just combining the numbers, because really what we're saying is I have 3, for this one here, I've got 3x cubes. I have one more. If I add them together, I have a total of 4. The only way the exponents will change is if we are multiplying. Because really this is saying I have 3 times x times x times x. Because x is being multiplied by itself 3 times. So that's what it's saying with an exponent. It's just telling us how many times it's being multiplied. Huh? Yes, I'll let you all know here after we finish the lesson. So any questions on this here, this vertical form? This is vertical, we're adding straight up and down. Or we can do it with subtraction, we would be subtracting straight up and down. Now we also have horizontal. And we do this horizontally. 9y cubed plus 3y squared minus 2y plus 1. And we are, again, adding to it negative 5y squared plus y. So horizontal. It's straight across. So when we look at this here, we're adding them together, yes? So since this is plus, will any of the signs, let me get a highlighter, inside of this here change? No, because positive is not going to change the sign. If we were subtracting, then the signs inside here would have changed. Then the signs would have changed. So really, I can just drop the parentheses. Like this here. Now, if it had been subtraction, we would have had to move that subtraction, that negative, through everything in the second set. But here we don't have to. Any questions on any of this here so far? Almost. What I'm going to do is I'm going to reorganize these just so it's easier to see what's going on and put the terms that are like each other next to each other. Well, I don't have any, I have 9y cubed. I have no other y cubed terms, correct? So, okay. Then I have plus 3y squared. Well, there is another y squared term. So I'll move it over next to it, minus 5y squared. minus 2y. Well, we also have plus y, plus 1, and minus 4. So I just reorganized them, reordered them, so that the terms that are like each other are next to each other. Now we simplify. So 9y cubed won't simplify because there's no other terms with y cubed. There's no other like terms with it. So we leave it alone. Yep. 3y squared minus 5y would be minus 2y squared. And yes, it's just another step. Negative 2y plus y would be minus y. And 1 minus 4 is minus.
Will it ever come in handy when you need to do it horizontally versus vertically? No, just an extra way to do it.
It's just another way to do it. Because when we're solving equations, normally we do it this way, horizontally, because we started rearranging and moving stuff. But if we're just working with equations, I feel sometimes it's easier to do it vertically because it's easier to line things up. Because if I can line it up, it's easier to keep track of what's going on. Questions on this here? Okay. So now we're going to add 2x cubed plus x squared minus 3x plus 4 and x cubed plus 7x squared minus 2 in a vertical form. So I'm going to just write the first one down. So I have 2x cubed plus x squared minus 3x plus 4. This is in standard notation, and we're not missing anything. Because I have x to the third, I have x squared, I have x to the first. Well, it's just x. And then I have a constant term, yes? There's nothing missing in there. So that's good. Because if we had been missing one of the terms, I'd leave a little bit of a blank space to kind of make room for it. Now, if we look at the other one, we have x cubed plus 7x squared. I don't have a term with just x, do I?
Nope.
No, so I'm going to move over minus 2. So I leave a blank. I leave a blank space here because if I write something there, there's a chance if I'm not paying close attention to it, I will combine those terms. Because if I'd have moved and wrote it like this here and I'm rushing, there's a chance I'm going to combine the 3x and negative 2, negative 3x and negative 2, when that's not supposed to happen because it's supposed to be over here. Y'all see how that works?
Yep.
It's easy to get stuff of these here combining the wrong things if we're not paying attention. So that's to help us. And then we're going to what? Add. I didn't do this on the first one, but it'll be helpful, especially with subtraction, to just go on and put the addition sign all the way through. Because it's just reminding us. That's all it is. It's just a reminder. I'm doing 2x cubed plus x cubed, which is 3x cubed. X squared plus 7x squared is plus 8x squared. Well, there's nothing here, so it's just minus 3x. And 4 plus negative 2 is plus 2. And that's it. Questions on this here?
It's going to be my favorite thing.
Are we good with addition? Because I have a feeling we're pretty good with this here. Do we need to see another example of horizontal? Why don't I go on and do it? Because I feel like some of y'all have already done this. Yes? Okay. I'm going to just go on and work this one through. Because we'd have our first equation. Squared minus 6y plus 9. Well, I know. Huh?
Is there a good chance you're going to make this right out of steps?
No.
Okay. Gotta make sure, because I guarantee I'm never going to do horizontal correctly.
Because if I'm doing this, because I would do the step, I kind of drop them just to make sure I'm keeping signs correct. Well, there's nothing with y squared. 2y squared and, I say, okay, I mark it. 2y squared and y squared, if I add those together, that gives me plus 3y squared. Negative y, negative 6y, added those together would be negative 7y. And plus 2 plus 9 would be plus 11, and we get this here. And that's all we have to do for these here. Yes. Any questions on this here? Now, did you notice something that I did with each one of these numbers? I marked them with different things because what I'm doing personally is, this here is not that bad. But when you get into upper level math and you're simplifying stuff like this, you're going to get a lot of terms. Because this here, the highest term is 3. If the highest exponent is 5, you're going to have at least twice as many, or kind of somewhere around there. 1, 2, 3, 4, 5, 6, 7. So somewhere around 14 to 15 terms where these are repeated over and over again. So I use this way of marking them to make sure when I get done adding and subtracting and combining like terms, I can look through here pretty easily and say, did everything get covered? Did I make sure I combined everything? Well, yes. And I keep the same symbol for the same terms to making sure I got them correct. I connected them together. Does that make sense? Now, I could cheat with this here because I've got green, I've got red, blue. Like, I can do different colors. I can even get this here. Do y'all have different colors easily at your disposal? I mean, you might, but most of the time, I just had a pencil in college. So I used these here because it's easier if I just have the same color to do different lines.
Is that yellow?
Yep. Okay, subtraction. Subtraction is going to be very similar. Okay, I'll hear it in a second. So this is our first one here. So it's kind of similar to what we've done with addition so far, yes? So let's look at the other one. We have 8x cubed minus 3x squared minus 2x plus 9. So far, nothing's different from addition, correct? But this time we are subtracting. So this one here, it would be good to write that negative, that subtraction sign all the way through. Addition's not too bad. Subtraction, it's going to help us keep things straight. Because when I do this here, 2x cubed minus 8x cubed, does it mean 6x cubed? That's not that bad. And when I look at the next one, 6x squared minus negative 3x squared. Well, negative and negative make a positive, which would be 9x. Negative x minus negative 2x. Well, the negative and negative would make a positive, which would be plus x, because negative x plus 2x, 2x minus x would just give us positive x. And last but not least, 1 minus 9 would be negative. And that's it. That's all we have to do for this here. Questions on this one here? We're good with that there. Let's look at horizontal. So again, I'm going to put the parentheses, 3z squared plus z minus 4 minus 2z squared plus 3z. So this is very similar to what we did first with addition, yes? We put them both down, we had an addition sign in the middle, and we put up the parentheses. Now with addition, the parentheses really didn't matter. We just dropped them and moved on. But because of this subtraction, it has to be applied to everything inside the parentheses because we're subtracting it, yes? So the first one's still going to be 3z squared plus z minus 4. It's not going to change. But this 2z squared is now going to be negative 2z squared. This 3z is now going to be minus 3z. It's going to change the signs of what's inside the parentheses. It's going to change the signs of what's inside the parentheses because we're really multiplying through by negative 1. Now it's going to be the exact same because we're going to reorganize them. So 3z squared minus 2z squared. We put those together. Plus z minus 3z. And then I just have minus 4. So these went together. These went together. And he's by himself. Well, 3z squared minus 2z squared is z squared. Z minus 3z would be minus 4. That's it. That's all we have to do with these here. Questions on these here? Any questions on any of these here so far? We good with addition and subtraction? Yes. That's it. That's all we really have to do. We're just combining like terms by either adding them together or subtracting them from each other. And that's it. I feel like y'all feel pretty good with addition and subtraction, yes? So,
What sketch do we have is fine.
huh?
Status check we have is fine.
Sum is addition. Difference is subtraction. It's just another way to say, huh?
Is it like either or we have to find both?
Subtraction. Yeah. When it says find the sum or difference, it's just asking. So, like this one here, because it's minus, it's a difference. It's already told you. It's just simplifying these.
Okay.
So, are we good with those there? Yes? Okay. The other thing that we're going to look at is multiplying polynomial functions vertically and horizontally. We're not going to do vertically. We can do vertically. It would be the same as doing like this here. 324 times 12. Well, we multiply by 2. 2 times 4 would be 8. 2 times 2 is 4. 2 times 3 is 6. We put a 0. 1 times 4 is 4. 1 times 2 is 2, and 1 times 3. Add 8, 8, 8. So I don't do vertically because I don't see a whole lot of point into it. So what we're going to mainly do is horizontally. Is this here. We're going to do it like this here. And then we're going to distribute. So negative x squared times x would be negative x to the third. Because when we multiply like bases, we add the exponent, so squared and 1. Now, negative x squared times negative 3. X squared. The negative and negative make a positive, and 3 times x squared is going to be 3x squared. Okay, we finished with that one. Positive 2x times x. We're going to do this here. So plus 2x squared. Now 2x times negative 3 would be negative 6x. And then our last one would be 4 times x and 4 times negative 3. Well, 4 times x would be plus 4x. And 4 times negative 3 would be negative 12. Any questions on this here so far? We good with all this here, yes? Okay. Well, we're not quite done because we need to combine like terms. If there are like terms, we need to combine them. Well, there's no like terms with x cubed, so we can leave it. But 3x squared plus 2x squared is plus 5x squared. Negative 6x plus 4x would be minus 2x, and then minus 12. And that's it. Questions on this here?
So the more we go, the more we're just going back down to the addition.
Yeah, it's just the distribution property. We just have more of them. Because up until now, I mean, the biggest things you've ever done is x minus 4 times x squared plus probably done something like this here, 2 terms and 2 terms, or 1 and 2 terms, or 1 and 3. We've not really dealt with a 3 and 2, a binomial and a trinomial. Questions on this here? I mean, we could see more terms. Yeah. So we look at this one here. Now we have y plus 5 times 3y squared minus 2y plus 2. So this one's different because the binomial is in front, the trinomial is in back. So binomial means what? Bi is 2. Polynomial, because these are all polynomial. What does poly mean? Multi, many. Multi-many. So polynomial, nomial, we're talking about these termed figures, these term sets. Poly, many terms, polynomial. Binomial is 2 terms. Trinomial is 3. That's what they would be called. Is a trinomial, binomial. Because we talked about last chapter, a perfect square trinomial had 3 terms. It's a perfect square. So, just some words. So we're going to start off by distributing the y. Well, y times 3y squared would be 3y cubed. Y times negative 2y would be negative 2y squared. And y times 2 would be plus 2y. Questions on this here? Any questions on any of this so far? We good with this here? Now, did you notice something that was different than the last one? Because on the last one, we had the first term, the cubed was unique. Then I had a squared term, then I had a squared term, and they kind of matched up. They're not going to match up here, are they? No, because I already have negative 2y squared and 2y, yes? So let's see what happens when we multiply through here. What is 5 times 3y squared? 15y squared? So there's 2 ways we can do this, and I'll show you the first way, what the textbook's going to say, is we're going to put it right here. Then we'll do 5 times negative 2y, which is negative 10y. And 5 times 2 would be plus 10. Well, now we need to rewrite it so the like terms are next to each other. That's what, if you need to, that's what I would do. Well, 3y cubed would stay there. Negative 2y squared. Well, its like term is plus 15y squared. Plus 2y, and then our minus 10y plus 10. Three y cubed doesn't have any like terms, but negative 2y squared and 15y squared do, so I get plus 13y squared. 2y minus 10y would be negative 8y plus 10. Questions on any of this here so far? So it's just combining like terms, yes? And this is what the textbook would say. This is how the textbook would say how to solve this. Erase that. Okay, I'm going to have to... I would have done it like this here. What have I done differently? What did I just do? I lined them up. I lined up what's like. Well, there's nothing with 3y squared, is there? So it's just this. Negative 2y squared plus 15y squared would be plus 2y plus negative 10y would be minus 8y. It's not really any different, is it? This here is just an easier way to line them up, yes? It's just an easier way to line them up. Questions on this here? Okay. So any questions on multiplication? We good with this here, yes? Okay. Another example of multiplication? Let's do this one. Multiply x minus 1, x plus 4, and x plus 5 in a horizontal format. X times x would be x squared. X times 4 would be negative 1 times x. And negative 1 times 4 is negative. Any questions on this so far? Any questions on anything we've done so far? Huh? So we're good with getting to this first step? Yes? Combine like terms first before we do anything else. Because the like terms we can combine are 4x and negative x, which would give us plus 3x minus 4. Any questions on this here? We'll do it again, because again, we need to multiply these. So x squared times x would be x cubed. X squared times positive 5 would be plus 5x squared. Then 3x times x and 3x times 15. Well, 3x, positive 3x times positive x will be plus 3x squared. 3x times positive 5 is going to be plus 15x. Negative 4 times x and negative 4 times 5. Well, negative 4 times x would be negative 4x. Negative 4 times positive 5 would be negative 20. Any questions on how we got to this here? We good with this here? X cubed. Combine like terms. Well, 5x squared plus 3x squared would be plus 8x squared. 15x minus 4x would be plus 11x minus 20. And that's it. So even when we have more than 2, it's still the same process, isn't it? We're just distributing one term at a time. Questions on this here? Any questions on any of this here? We good with this here? Do we need to see another example of one of these with 3? We're good with all these here? So, I mean, we do have some special patterns kind of going backwards like these here. Now, it's almost like we had with this here. It's kind of like the difference of perfect squares, yes? So what it would say, if I know the difference of perfect squares, I would do 4n times 4n, or 4n squared. Well, 4 times 4 would give me n squared. Minus 5 times 5 would be, if I know that this is a difference of perfect squares, I can jump to this here. Or if I multiply it out, well, 4n times 4n would be 16n squared. 4n times negative 5 would be negative 20n, yes? 5 times 4n would be plus 20n, and 5 times negative 5 would be negative 25, yes? These middle terms cancel, and I'm left with this here. Does that make sense? So some of these here, we can do it this way, but there's nothing wrong with working it out. There's nothing wrong with working it out. So if you don't immediately see, oh, 4n plus 5 and 4n minus 5 is a difference of perfect squares, I can square the first and second term, and we're done. Don't have to do that. So 9y minus 2 squared, that's the same as saying what? 9y minus 2 times what? Because whenever we have that power, it's telling us that thing is being multiplied by itself twice. How many times would I multiply ab plus 4 by itself? 3 times, because it's to the third. Now here, we get 9y times 9y, which would be 81y squared. 9y times negative 2 would be negative 18y. Negative 2 times 9y would be negative 18y. Negative 2 times negative 2 would be plus 4, so I get 81y squared minus y plus 4. Any questions on any of this here? So any questions on any of this here? So the overall process for each one of these here changes a little bit, but it's just, we're doing the same steps. We're doing the same steps over and over again, yes? Now, okay, I want a new slide. And this is going to be easier to do with x plus 1 to the 6th power. So that means x plus 1 would be multiplied by itself how many times? 6 times, yes? Now, for those watching the video, I showed this first. This here is called Pascal's triangle, or a factoring tree. It will come out here in a few weeks after Thanksgiving. I have made one with ornaments and actually dressed it up like a tree. So we're saying we're multiplying this by itself, so it'd be x plus 1. So there's 1, 2, 3, 4, 5, 6. We're multiplying it by itself 6 times. This would end up being x to the 6th plus 7x to the 5th plus 21x to the 4th plus 35x squared plus 35x. Let's see here, make sure 5, 4, no, this should be 3. Plus 35x cubed plus 35x squared plus 21x. Make sure I'm still on 6, 5, 4. Is 1, 7, 21. Make sure I did this right. 7, 21, 35, 35. Ah, that's where it was. Nope, that should be 21, 7. Nope. Here. 35. No, I'm just was trying to do that way too fast. So 7, 21, 35, 35, 21. So 6, 5, 4, 3, 2. Okay. Oh. 1, 2, 3, 4, 5. Ah, that's why. Like, that didn't make sense.
Why?
4, 3, yes, that's it, 6. So, that's why that's not working out right. Because I was doing not the 6, I was doing actually the 7. Because this should be x to the 6 plus 6x to the 5th plus 15 squared plus 20x plus, if I can count, 4th, 3, being x squared plus 6x plus 1.
So who got so bored that they decided to equal to themselves without
7th. Now this seems like it is really crazy, but based off of this here, if I have the triangle, no matter what power it is, I didn't have to multiply any of these out. No. Because most of these here, if we did have it times itself by 4 times, these here are the numbers that are going to be multiplied in front, whatever A and B is. I chose 1 and 1 because these are just the numbers. But it kind of helps us see what are the terms, what would they be. So it's a faster way to write it because it tells me how it's going to work out, how these variables are going to work in place. So it's a faster way to multiply these together. It's kind of a cheat sheet on doing these multiplications. Because otherwise, like for the 5th, I would have had to multiply that thing by itself 5 times. Like how we did it with just 3, it took a decent bit, let alone doing it 2 more times on top of that. Yes, it's just going to take a minute to do them. Any questions on any of this here?